reliability, speed, precision. You're hitting all the above, which results in overall productivity. Fantastic technology that you have there at Blum Novotest. You know, with so many distractions on today's day and age, some have issues focusing on productivity, but today we're focusing on just that. I'm hanging out with Casey from Blum Novotest. First and foremost, how you doing today, man?
I'm doing well. Thanks for asking. How are you doing?
Hey, it is well, and it's a great day to talk about accuracy, precision, and productivity. So we're hanging out here with you, Blum, as well as Starrag sitting in front of an amazing machine. Why Blum Novotest? Why Starrag? What's going on here, and why do we need to know more about it?
Yeah, sure. That's a great question. You know, at Blum, we have some core principles. You know, we focus on fast, precise, reliable. When we evaluate partnerships, there's occasions that those same principles kind of come to the surface rather quickly. So with Starrag, after dealing with their staff internationally, also on a local level, working with Udo, it was very clear to us that this was a partnership that made great sense. Our product paired very well with their machine. It was very complementary of precision with precision. So from that standpoint, taking that journey to how do we work together, it was a very simple, very quick conversation.
No, it sounds synergistic, and that's exactly what we're here to do and to focus and feature. But knowing this, we're talking about measuring tools. Now, everyone has their own ideology or thoughts on that specifically, but if someone was to come to you and say, why are we still even measuring tools? How would you answer that question?
Yeah, sure. That is a daily question that I am asked, and it's a really simple answer. You have all this data at your fingertips outside of the machine, but also that same data is inside the machine, and how you get that out of the machine, that's kind of the task that we have at hand. So once you have that tool information in your control, once that tool touches material, that data is useless until you get that measurement of that tool inside the machine to say, how did my tool perform in that cut, in that moment? Is it still in a state where it can continue to cut and make parts within my tolerance? So, we have a philosophy and a measuring strategy that we measure tools at their nominal cutting speed. So at 10,000 RPM, a tool looks a lot different than it does when it's not moving. So that is why we measure tools in the machine, is just to keep that productivity, keep hands off the control, and keep all that tooling data as current as possible.
This is intriguing to me, and with a tagline like focus on productivity, how are you allowing just that to happen with manufacturers across the globe?
Sure. So, to be productive, you want that machine door closed as much as possible. To do that, to ensure that your machine is cutting chips, sometimes you have to measure those tools after the cut. That way you can ensure that tool is going to continue to make quality parts and you're not running scrap all day.
No, true story. And for those who may be hesitant or resistant, or maybe not as aware of the technology that you're bringing to the industry, what's one of your favorite factors and features from this specific technology?
I would say my favorite thing about our latest and greatest technology, the LC50-DIGILOG, is just the combination of two different technologies. I think a lot of people get hung up on, the digital side of technology and communication, where we found that the combination of digital and analog was actually the ideal answer, to the problem that no one really knew they were having. So being the first company to take those two data communication, those two data streams, and combine them together has been a big benefit for us to increase productivity and decrease measurement cycle time.
There you go. Hey, in God we trust. Everybody else bring data, and you are not only bringing data, you are combining data, and that leads to efficiency and results. Anything else that you would love our audience to know about your incredible technology or your relationship in synergy with Starrag?
Yeah, so what we enjoy most about working with Starrag is just the mirror image of our product and their product. I always tell people, you're not going to put a Corvette motor in a Ford Focus. So what Starrag does with our product, I think, matches their image well, and I think their equipment really highlights our accessories as well. So it's a great partnership, and we're really excited to see how much further it goes.
So even as a guy who's not a machinist, as soon as I found out they're measuring things with lasers, I was totally sold. But what I understand is that what Blum is doing with this laser and measurement technology, you're doing something special. What do we need to know?
Yeah, so we've really kind of changed the core focus of how our product interfaces into the machine tool, how we communicate with the machine tool, how we monitor the tooling live in action. So just a little bit of a background and detail into that is for years and years and years, there's been this core focus on digital communication. Digital is the future, analog is dead. What we found was the combination of using analog signal in conjunction with a digital signal was actually the best way to get a very high resolution look at that tool inside the machine tool with the contaminants, the debris, the coolant, the chips inside that machine. It was really important for us to find a different communication method where we're able to dwell that tool in the beam and gather hundreds of thousands of measuring values per second. So for me, I compare it from a standard definition TV to your 8K high def.
Solid comparison indeed. And then knowing that, why does this truly matter and why should individuals really be paying attention to this technology as it advances?
So the honest truth is a lot of people don't buy a machine tool to think, I cannot wait to get that machine on my floor and measure my tools, right? They always think, I can't wait to get that machine on my floor so I can cut parts. But honestly, there's a really good argument to be made that the making of parts is important, but more important than just kicking a part out is kicking out a part that's in tolerance and not scrap. So where we come into play is we're offering you the LC50-DIGILOG system, and on the market today, it is the fastest tool measurement system that you can buy. So with the Starrag machine and its extreme accuracy, it is a perfect fit to have our LC50 in this machine. So we're matching speed with speed, we're matching precision with precision, and reliability with reliability.
When people are making chips, Casey, I feel like the cutting tool gets all the credit, but no one likes to talk about the software or give it the credit that it's due. Not today. We're going to be giving credit to real, true, innovative software that you're going to tell us all about. What do we need to know?
Yeah, so we have a newly released software that works with our hardware solution, the LC50-DIGILOG. Our software that works along with it is LC Vision. A lot of people would say, oh, LC Vision, what is that? In a very brief overview, LC Vision is an intelligent software solution that gives you the ability to have these visualization of the measurement in real time. There's auditory learners, or visual learners, there's touch learners. This kind of just gives you that ability to now see what's happening inside the machine in real time, so we can measure the full contour of that tool, we can measure each cutting edge of that tool, and we can do that very, very quickly and very reliably. Once upon a time it was, what do you want to measure on your tool, your length or your radius? Well, now, beyond these standard functions of our laser, we have advanced functionality with LC Vision. These advanced functions, just to kind of go into brief detail of a couple of them, 3D tool control. What 3D tool control allows you to do is it gives you the measurement along the contour of your tool, as well as each individual cutting edge of that tool. Not only your longest, which historically has always been your radius of your tool, your longest cutting edge, the part of the tool that contacts the material first. That's your diameter or your radius. What we do is we gather the longest edge and the shortest edge and each edge between the two. So now you have your deviation from shortest to longest. Consider that your run out. You also have your longest edge. So now you have that insurance that the part that you're machining is going to continue to be in spec.
So much data, so much information. We don't even know what to do with all of it. But knowing that, what are individuals doing and how are they making better decisions with the data that Blum provides at the spindle?
Yeah, a lot of the data, it's more than the average guy needs. But what people do with it on a 3D tool control measurement where you're getting the full contour of that tool, you're now able to take those measurements and best fit that tool in the machine to now maximize those offsets and really give you all the cutting edges engaging in the material at an ideal state.
And then knowing all of this information, how is this changing the game for end users?
Well, it's really given them the ability to do more in the machine, keep the door closed, have less operator intervention. I'm always leery of using the term unmanned machining, lights out machining, hands off machining. But what this has given you the ability to do is it's keeping those fingers off those buttons, saying my 6-inch drill is 6 inches, when our laser is going to tell you that 6-inch drill is 5.999. 1 micron doesn't matter to a lot of people, but to some it does. And we give you that information and allow you to make the decision on what to do with it.
So Casey, from what you've described, this software does pretty much everything. What have we missed and how can it possibly do any more?
Yeah, so, we covered some of the basic functionality of the laser. We talked a little bit about the 3D tool control. We actually have a few more cycles that are in the advanced functionality of the LC50-DIGILOG and LC Vision. One that I'd like to focus a little bit on is our spindle control cycles. What we do is, with the spindle control cycle, the primary use of a laser is to measure tools in the cut, make sure that the tool geometry is getting back to the control. What we also give the user the ability to do is analyze the health of their spindle. The way we do that is similar to measuring a tool. Instead of a tool, we use a reference tool. We know the geometry of the reference tool. The control knows the geometry of this reference tool, and it's a very precise tool. So we'll dwell that tool in the beam, and from that, we can actually gather information like axial runout of the spindle, radial runout of the spindle, frequency, harmonics. And what's that gives you the ability to do is it gives you the ability to predict that health of your spindle and predict when it's time to say, I have a 10-hour cycle coming up and I'm not sure my spindle's going to make it. Let's get some preventative maintenance in here and let's schedule that spindle to be repaired just to ensure that our next part is going to come off that machine well and we're not going to have unplanned downtime or a catastrophic failure mid-cut.
Now, my mother always said that looks don't matter, but I know to some manufacturers it means the world, and we're talking about surface finish. Now, how does Blum help manufacturers around the world ensure they have premium and optimal surface finish?
Yeah, that's an interesting question. We're seeing it more and more frequently where surface finish requirements are a very high priority for our customers, especially in high-end manufacturing, aerospace, medical, but even in automotive, rocker arms, bearing seats, valve seats, cylinder bores. These all have critical surface features, surface finish requirements as well. What Blum does, we're very unique to where our standard interface for our machine, our receiver, our back-end wiring, we use a common interface that you can have your standard probe for doing point-to-point measurements, basic measurements, offsets, part pickup, things like that. But we give you the ability to also pair advanced technology probes to the same receiver. So once you make that first investment, it becomes very easy to now justify, how do I get to the next level? How do I control my process in greater detail? And we give you that ability with our TC64 roughness gauge. Checking surface finish has always been a very manual process, and you can line up 10 people with one profilometer in the same part and they're going to give you 10 different surface finishes because this is such a finite way of doing things that there's a lot of user error. What we do is we take a machine such as a Starrag machine, which is going to repeat to micron, submicron level, and we give you the ability now to check that surface finish inside the machine in an automated fashion through the coolant, through the chips, through the debris, and we're going to give you more data than you could ever want. We're going to give you your RA, RT, RQ, RZ, R min, R max, W profile, and all of this data gives you the ability to now make educated decisions based on, is that part good enough to come out of the machine? Yes, it is. Was my surface finish degrading to a point to now where I need to analyze, is my finish tool in a state that it can continue on? These are really important things that weren't possible once upon a time. And at Blum, we kind of pride ourselves on the innovation of in-machine metrology. To some people, it's not the most exciting thing, but in manufacturing, when you talk about controlling a process in the machine, you'd be surprised at the level of excitement that you get from that.
What situations, scenarios, and circumstances will a tool and technology like this maximize the value to the end user?
So there's two different markets that really look at this type of product. So we have, high production. I don't have time to stop my machine. I got to keep cranking out parts. Well, with our RG probe, we need to check just a very small section of that critical feature. We're not asking you to scan the entire profile of a part. Find that critical feature that you don't want being missed or sent down the line, where it's getting caught down the line and we're catching it in the machine. Find a small section of that part and we can get perpendicular to the surface, scan it, and give you that data. So now you're confidently taking that part out of the machine and sending it down the lab and now putting a raw part in. But also on the low volume parts, we also justify it by low volume, high value. So you have a high value part and you take it out of the machine and find out your surface finish is bad, you have more problems than incurring an additional 5 to 10 seconds of cycle time.
God, we trust. Everybody else bring data, and you are not only bringing data, you are combining data, and that leads to efficiency and results. Anything else that you would love our audience to know about your incredible technology or your relationship and synergy with Starrag?
Yeah, so what we enjoy most about working with Starrag is just the mirror image of our product and their product. I always tell people, you're not going to put a Corvette motor in a Ford Focus. So what Starrag does with our product, I think matches their image well. And I think their equipment really highlights our accessories as well. So it's a great partnership, and we're really excited to see how much further it goes.
There we go. Putting Corvette engines in Corvettes, making things the way they need to be done. Hey,
no disrespect to Ford Focus owners.
Hey, there we go. None taken. We're doing great here. But thank you for everything you do and focusing on that level of productivity and efficiency that you're bringing. Fantastic to hang out with you, Casey, here from Blum Novotest. Hey, we'll see you all next time.